All right, Pythagorean theorem. Have you guys seen this before? Yeah. Yes? Do you guys remember the formula?
B squared plus B squared equals C squared.
Good job. All right, so we're going to write that down here. What is it? We're going to have our picture ready and everything. Pythagorean theorem. Now, Pythagorean's theorem only works for what type of special triangles? Right triangles. They have to be right triangles in order to use this. Now, where your legs are A and B and your hypotenuse is C. So when you're doing A squared plus B squared equals C squared, you want to make sure that your hypotenuse is labeled C in order for this to work. All right, let's write it down. A squared plus B squared equals C squared. A squared, leg squared plus leg squared equals C squared. Does it matter which leg you label as A or B? No. AB, BA, as long as C is your what? Hypotenuse. Your longest side. Yep. Good. Okay. Find the missing side. And I'm going to put in parentheses here, radical form. And I will tell you this. You will always write it in radical form unless specified, unless asked otherwise. So if it says round to the nearest tenths or nearest hundredths, then you're writing it in decimal form. But if it does not specify, which form do I always want it in? Radical form. Again, unless it's specified otherwise. All right, number 1, let's draw our picture. I'm going to label this leg here as 6, this leg here as 4, and the hypotenuse as x. Okay, does it matter which one you call A or B?
No.
Does it matter which one you call C?
Yes. Yeah.
Which one is C in this case?
X.
X. How do we know that? Because it's missing. How do we know it's C though and not A or B? Yes.
Because C is always the hypotenuse.
C is always the hypotenuse, and I heard it stated another way. It's always the what? Longest side. All right, it's always opposite the 90. Yes? All right, here, if this one is C, does it matter here which ones I call A or B? No, this could be A, that could be B, or A and then B. It doesn't matter. As long as you're squaring your two legs. So I'm going to write 6 squared plus 4 squared equals x squared or c squared. You can call it c, that's perfectly fine. All right, you can do this part without your calculator. What's 6 squared?
36.
What's 4 squared? Equals x squared, and you have to square root them first. What do we get? I'm sorry, you have to add them first. What do we get? 52 equals x squared. So you guys have seen the whole, what do we do to both sides here to solve this? So you guys have seen that before, what I mentioned earlier. What happens with the square root and the squared? They cancel out. And I showed you guys earlier why that happens, correct? We talked about pairs. Do you guys remember that? All right. Square root of 52. Is 52 a perfect square? No. So I'm going to break it down. It's even. You guys have your calculators, or you can do it in your head. So I know for sure 2. And then divide it by 2 and see what you get. What is it? Is 26 even? So we know we have at least one pair. There's a 2 and a 2. 26 cut in half. What do you get? 13. So I have root 2 times 13. Now you see why we did all that review that we did yesterday. What pair comes out here? 2. And it comes out as 2. What remains inside?
13.
So x equals 2 root 13. That's as far as you can go. That is your answer. Now I put x equals. If you put c equals, would that be perfectly fine? Yeah. Any questions here? We're good? Okay. Review. You guys have done this before? Last year in Math 1? Yeah? It's been a long time. All right, next one. ready. Okay, first thing you should always recognize is where is your C, the 3, the X, or the root 15?
Root 15.
The root 15. Why? Because it's always opposite the 90, the right angle. All right, so your C will not always be X. It's not always going to be the side that's touched, like the base or the height. It's always going to be opposite the 90. So your right triangle may be flipped around. Be careful. All right, here, does it matter which one I call A and which one I call B? So, does it, well here for A and B, does it matter which one's A, which one's B? Okay, I have a question for you guys. Does it matter how I label it? For example, could I do this? 3 squared plus root 15 squared equals x squared. Is it okay to write it that way? No, writing it this way is telling me what about side x? Side x is, according to this, side x is hypotenuse. And is it the hypotenuse? No. So be careful that you're labeling things properly. If this is the hypotenuse, this is your A and B. So I'm going to write 3 squared plus what squared? X squared, good job, equals what squared? Root 15 squared. All right, we just talked a second ago. What happens with square roots and squares? What happens to them? So what's the square root of 15 squared? 15. Do you remember when I asked you guys earlier, when I wrote it this way, root 5 squared is 5, and I asked for a really big number? You guys remember that?
Yeah.
So we talked here that what happens with square roots and squares, they do what to each other? They always cancel each other out. Why? Because squared means you have a, what's the word again? A pair. All right? So, and this one here, what does it equal on the right-hand side? It's just what? 15. 3 squared is 9 plus x squared. I can't square root everything, but I can subtract what to the other side? Minus 9, minus 9. And that gives me x squared equals 6. I'm going to move my work over here. X squared equals 6. Now what do I do to both sides? Square root. Square root, square root.
Oh, wait a second.
Does 6 break down or is 6 prime?
3.
6 is in prime. It does break down. What does it break down to? Does it not into a pair? Does it break down into 2 prime numbers? So nothing's coming out. So first off, what happens here with the square root and the squared? What does x equal? Root 6. Why root 6? Because there's no pairs that come out for 2 and 3. Ask me your question.
I don't know my question.
Okay, I'll give you some time while I start to write down the next one. I'm going to give you some time to process. Ask me your question.
I was confused then because we had to look for X.
Oh, up here, find the missing side? Yeah. So is X always going to be your hypotenuse? Is it always going to be your A or your B? No, you just have to look at the problem and figure out what is X. In this case, X is a leg. In this case, X is the hypotenuse. So it all depends on how your picture is drawn. Did you figure out your question?
No, I'm just keep going. I'll figure it out.
A equals root 7 kilometers and B equals root 5 kilometers. All right, what's the missing side here? C. And we're assuming here it's just like this one up here that C is your hypotenuse unless stated otherwise. So C is what we are looking for. All right. A squared plus B squared equals C squared. What's A in this case?
7 squared.
So root 7 squared plus B is root 5. So root 5 squared equals, you can call this X, or since they didn't give us a letter, could you just call it C squared? Sure you can. All right. Without any work, what do we know here about the square root and the squared?
7.
7. They cancel out. It's 7. Square root and squared cross out, so it's plus what?
5.
Equals C squared. I'm going to let you guys finish it from there. And there is some breaking down on this one that needs to be done. And pairs taken out. What's 7 plus 5? Okay, what do we do to both sides? This cancels out. C equals, does 12 break down? And it does have a pair? Because it's, what did you guys use to break it down? 2 and 6? And 6 is? Did anybody use 4 and 3 instead and still get the 2, 2, 3? Yes? 2, 2, 3, what comes out? The 2. And so what does C equal as the final answer? 2 root 3, radical form, unless stated otherwise. Okay, questions on 1, 2, or 3? Easy, easy peasy, feels like review. All right, number 4. Oh. What was that?
She thought I was playing her out.
Okay, number 4. Is the following triangle a right triangle? Okay, so I'm going to give you a triangle. We know it's a triangle, but is it specifically a right triangle?
Nope.
So, you said no. So you can't just say it looks like a right triangle. Okay? Now, I'm not giving you any box in here. Do you see that? Now, I purposely made it look like a right triangle, but since I did not put the box, can we say it's a right triangle? No. Okay, 9, 9, and root 181. Okay, so how is this one different? Are you missing any sides here? No, everything's given to you. Are we still going to use Pythagorean's theorem? Anybody tell me how we're going to use Pythagorean's theorem to see if this is a right triangle? It is isosceles. You are correct. Yes.
Hypotenuse is bigger than both of the sides.
Okay. The hypotenuse has to be bigger than each side. What's 9 squared? 81. So the square root of 181 is bigger than the square root of 81. So it is bigger, but does that mean it's a right triangle? No. So far you guys are correct. It's isosceles. This is the longer side. We can tell that much. Anyone else? How can we use a squared plus b squared equals c squared? I'm going to take a step back. What did I say in the very beginning? We can only use this on what? So this only works on right triangles can be isosceles. They can. This only works on right triangles. So what can I do here to see if this is a right triangle? Plug it in. And if it works, if it does work, is it a right triangle? Yes. If it doesn't work, is it a right triangle? No. So let's try. She said plug in. What do I plug in for A and B? 9 squared plus 9 squared equals, what is C? Square root of 181, and then I square it. What's 9 squared? 81 plus 81 equals, what happens here with the square root and the squared? And what do I end up with on the right hand side? 181. Can you guys quickly add up 81 plus 81, or 81 times 2? I'm sorry, what was it?
162.
Does 162 equal 181? It does not. If it does not equal, what does that mean about this triangle? It's not a right triangle. Definite test question. All right. So they'll give you 3 numbers and they'll say right triangle or not, and you plug it in. Really quick. Really quick. What if I didn't give you a picture? What if I only gave you 3 sets of numbers? Like I gave you 9, 9, root, what was it? 181. How do you know which one is C? Yes. The bigger one. So a few things you can do. You can plug the square root of 181 in your calculator. Can you guys do that really quick? What is the square root of 181? 13 point something?
Yeah.
Is it bigger than 9? So then this is your C. So when you're taking the test and you have a set of 3 numbers, the first thing you should try to find is which one is your largest. So you know which one is your C. Does that make sense? Yes? All right. Number 5. These are definites as well, not only on the test but on your homework tonight. A 15-meter ladder is leaning against a wall. 15-meter ladder is leaning against a wall. The bottom of the ladder is 9 meters, not a period, is 9 meters from the wall, period. How high up on the wall does the ladder reach? How high up on the wall does the ladder reach? Does the ladder reach? Okay. First thing we should draw is our picture. It doesn't matter if you draw your house here or here. I'm just going to put the house here. All right, there's our house. Okay, the ladder is leaning against. Now, what do we know about buildings and the ground? What angle is right here? A right angle. We don't need to be told that. We know buildings are built perpendicular to the ground, unless stated otherwise. Of course, there's some special rare cases, but unless specified, our house is perpendicular to the ground. All right, we have some numbers here. The bottom of the ladder is 9 meters from the wall. Oh, where does the 15 go? You're right, on the what? Hypotenuse. Why? Because the ladder is 15 meters long. So do you guys agree this is the ladder here? Yep. Yes? All right. The bottom of the ladder is 9 meters from the wall. Where does the 9 go? On the base or the height? Base. The base. Because it says the bottom of the ladder, this is the bottom of the ladder, is 9 meters from the wall. Do you guys see that? How high up the wall does the ladder reach? Are you guys agree they're asking for this height right here? I'm going to put an X. You can call it A, you could call it B, element OP, does not matter. I'm calling it X. I would not call it C because I'm saving C for the hypotenuse. Okay, do we have enough here to use Pythagorean's theorem? Okay, which one is your hypotenuse in this picture?
15.
15. So X squared plus 9 squared equals 15 squared. I'm going to let you guys do that. You guys have your calculators. You can go ahead and plug it in. Okay, what did you guys get? 2 root 11? 12? Wait a second.
What?
I asked what the answer was. I'm going to at least start it while you guys are still working it out. What did you guys get for 15 squared? Then I'm assuming everybody did this. Let's check. And then x squared equals, what does that subtract to? 144. Now you can break it down, but I'm hoping you have it memorized. If you don't have it memorized, can you break it down? Did anybody break it down? Would you like to see it? No, you knew it? What did you get when you square rooted both sides? What's the square root of 144? 12. 12 meters. So it is 12 meters up the side of the wall. Yes? Okay, number 6. The diagonal of a square is 10 root 2, period. The diagonal of a square is 10 root 2. Find the side of the square. Okay, what should we do first? Draw our square. Do you guys remember what a diagonal is? Yes? From one corner to its opposite corner, that's a diagonal. Okay, where does the 10 root 2 go? On the side of the square or along the diagonal? Diagonal? Oh, what's in this corner right here? All right, how am I going to find the side length? Anyone? Any thoughts? Do I have enough information to use Pythagoras theorem? I'm going to put a star by this one because this is an important one to know. That's a little trickier than the other ones we've done so far, and kids do struggle on this one. Okay, beautiful. I don't think anybody heard her, so I'm going to have her keep it, and I'm going to ask again. How can we solve this? I asked, do we have enough information to say a squared plus b squared equals c squared? And you guys said no. I'll give you a hint. It is a square. What do we know about the side lengths of a square?
All the same.
They're all the same. So if I put an x here, could I put an x here?
Yeah.
Now do I have enough to use Pythagoras theorem? Yes? Yes, what is it going to look like? X squared plus x squared equals 10 root 2 quantity squared. Lucky for us, these are like terms. X squared plus x squared, we can actually add them together. Before I go further, do you guys understand what was done here? Yes? Now, nowhere in there will they tell you, hint, it's a square, all your sides are the same. Do you need to know that on your own? Just like you need to know that's a right angle. So you know this is a right triangle, yes or no? Yes? All right, what's x squared plus x squared? The coefficients you add, what's 1 plus 1? So 2x squared equals, we did this on the last lesson. I'm going to put our little thinking bubble over here. What does that mean? 10 root 2 times 10 root 2. What's 10 times 10? 100 without using the number 4. These are pairs. So what's root 2 times root 2? 2. Do you guys see that? And what's 100 times 2? Okay. So 10 root 2 squared is 200. Now I often have kids doing this and get stuck here and I don't know what to do. Yes, you do need to do side work on this problem. Your side work is here. Okay, how do I square it? I write it twice. I know there's a pair, blah, 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 blah. We're here. Before I square root both sides, what do I have to do first? Not subtract 2, but you're close. Divide. Divide the 2. 2's cross out. And that gives me x squared equals 200 divided by 2 is what? 100. Do you guys see why kids struggle with this one? Do you agree there's a lot more work on this one? And we're down to our last step. What do we do to both sides? Square root. That cancels out. And do we have the square root of 100? What is it? Without breaking it up, it is 10. So the diagonals of the square is 10 root 2. Find the side. The side, each side is 10 units. Got it? Now, typically we do plus or minus when we square root, but we don't do it when we're working with these type of problems because our side lengths are always positive. Got it? Questions?